What is up, big nerds? I'm here. I'm just getting my stuff figured out. What's this? I'm adding fixing this overhead cam situation. Oh no. Where's my... Hello? Camera? Are you there? Let's see. Here I am. Welcome to the stream. Where's... I have to set camera mode on this thing. Webcam mode. Is it... Calculator, focus mode, recorder, live caption. No. Is it camera access? No. What the heck? I need this overhead camera to work as a webcam. And I also have to make sure I've set up the secondary screen here. It's gonna be black, I think, while I get this figured out. Let me see. Switching over. Yeah. So this device needs to be toggled. Nope, that's me again. That's what I want. Okay. Yeah, so technical difficulties. We're okay. Here we go. This device, webcam. Any way to have that saved? I don't think so. Okay, hopefully that's going to be a little bit more stable if I don't keep bumping it. But let me see. Let me bring it up here. Oh, bloody hell. Okay. Studio mode, please. Thank you for bearing with me. Is anyone even watching? Probably not. Usually someone does. Let's see. Overhead cam. Capture device. Properties. Switch back to the Android webcam, medium quality. That's pretty good. And then shift it over. There we go. Probably better aligned there a little bit. day. Oh, you can't see it there, but if I jump back here and make this big, check it out. That's what we did last time. It goes one character at a time and sets and says hello world. I wish it was possible to read from there. Maybe I just need to rearrange stuff a little bit to get it to look like what I want. But I don't know, we're pretty close. We're pretty close. I didn't find an SPI device that made any sense to use. So today is just going to be configuring the Wi-Fi and getting a connection. On the network, HTTP or whatever it is. Let me shrink this back to normal size here. So I guess the first thing I need to do is bring up the terminal. Compost Mon project. And it's still called Hello World. And what did I have to commit here? Some comment there, writing a data register. Okay, so this is the hello worlding code. We can do that. Git add flag u. Add hello world code for the first screen. And I can drop the volume of this a little bit. How's that? Don't be afraid to chat at me when I'm doing something wrong, or to ask questions. Oh, actually, first thing I should do, speaking of chatting, is go on social media. And say that I'm live. So today, I have a pretty hard end of stream time of 6 p.m. So probably just going to go the 4 hours and not very much longer at all. And I guess on Twitter, formerly normal. Okay, so give me a new post. Streaming now. 2 p.m. to 6 p.m. Eastern. It's daylight time. Let's see. What am I gonna do? ESP32 network connectivity. Oh, you can't see this. I guess I can show. Doesn't matter to me. ESP network connectivity and maybe some communication. Network connectivity. And maybe we'll do more stuff with the screen. I don't know. We'll have fun with it, but What is the link to my Twitch? How do I do that, actually? There's no ready-made. If I just send this. And then I'll do the same thing on the Mastodon. And I guess the same thing on Twitter. So yeah, I'll do a boop. Let's post that. Let's post this. Mount Etna is erupting. And then I'll post it on Twitter as well. And here we are. Okay. So, hello. Welcome to the stream. So, network connectivity today. I have to bring up the ESP32 documentation. ESP32 IDF is what it's called. And we need to make sure we're using the right device. This is an S3, latest stable. That's correct. API guides? No, API reference. There should be a network. Wi-Fi. Here. Ta-da! Okay, station mode or Wi-Fi client mode. ESP32 connects to an access point. That's what we want. And oh, I hope I don't have to show you my network password. I didn't think of that. Boop. I'm going to figure that out when we get there. Yeah. So, for anybody who's new, let's try to get it a little disentangled here. Unfortunately, you still can't see the hello world coming up on the screen. And it's kind of small, but that's okay. So basically, we've got our system on a chip thing is right here. This is the ESP32S3. It's a dev kit version 1.0. It has Wi-Fi and Bluetooth and stuff built into it, and it's currently connected to a temperature and humidity probe. It's this guy I'm waggling over here. And maybe I should try... No, but then you can't hear me, so never mind. I'll have to set that up some other time. But basically, this guy is connected via I2C. Set that up, and then that screen has an I/O expander that's also connected via I2C. Check out my last streams for info on that. But today we're gonna try to get this connected to my Wi-Fi network. Maybe I should pull out like an old access point and use that. If it comes to that, we'll do that. But for now, let's just assume we don't have to worry about it. So, we require ESP Wi-Fi, so we have to go in and configure that. Let me open up Emacs. Hello? Emacs? There you are. Okay, so in code projects, compost mon, and then hello world. I believe it's called main. There it is. CMake lists. We have to do. I don't know if. Might as well test this now. I don't know if we have to say if this takes like a list of things. So let's give this a shot. So we just list those. Whoops. Have them indent, please. No. We'll do it like this. String insert rectangle. It didn't like that. Oh, because I replaced. Okay. String insert rectangle. There we go. And now, let's see if that works. So back in my terminal, I have a alias for espenv that just calls this script here that does all the magic for you. So espenv will put me into this environment with a bunch of environment variables that the build system uses, and then we can run idfpy build. And right now we're just checking to see whether this syntax is correct. That looks good. I also need to add ESP Wi-Fi. I think that's the ESP Wi-Fi. I'll run the build, so then now my LSP server can pick that stuff up. And back in the main project, we're gonna have to start organizing this a little bit, because it's getting kind of unwieldy to just have everything in one main function. But we're just learning. The trouble with that, so I think what we do here, it might need to be its own free RTOS task anyway. But I'm not sure, so we'll have to learn. We'll have to figure that out. Let's see. So must be called, there's an init, there's a dinit, there's a set mode. I'm not sure if what are the modes? Let's check it out. Null mode, I don't know what that is. Station mode, that's what we want. I don't know what a NAN module is. What is Wi-Fi NAN? Is it like British grandma Wi-Fi? Neighborhood area network. Okay. It's for like mesh type Wi-Fi. Not doing that. So we want station. Let's see. Back in here, let's go to the top of main and run a where can we do that? After we print out a bunch of stuff here. Okay. Do we even use odd cycle? We do. Okay. So that's grouped with there. And in here, write that down. This Wi-Fi mode. Wi-Fi mode T. What else do we need? So Wi-Fi init. Come on. Hit. And then Wi-Fi dinit, I'm not going to worry about. Maybe it needs to, but perhaps not. I don't think we need to worry about that just yet. Wi-Fi set mode. We'll copy this function. Just give me the whole thing. There's that. And then get mode. This might be useful to check that we've initialized it properly, but then this is the main boy, I think. So Wi-Fi start. Start Wi-Fi according to configuration mode, yada yada yada. So this is starts it in station mode, and then we got to do restore. I don't think we need to do that. Wi-Fi connect. Yeah. If station interface is connected to an access point, call Wi-Fi disconnect to disconnect. So we might need this. No, not in there. Okay. Stub API, sure. Deauthenticate Wi-Fi scan. Scan parameters. Wait. Connect doesn't take any parameters, so then this is a different order, I think, because we're gonna need to do. It needs to know how to connect to something, so we have to tell it what that is at some point. Presumably, we have to scan. Oops. For access points. Set scan parameters, so might want to set that one first. And then get scan parameters, sure. Stop scanning. I don't know that we need to do that, but we might have to. I feel like it should stop scanning by itself, but where there's a start, we can add a stop. And what else? Get AP num. That's not what I would use. I would use count, but that's okay. I don't think we need this. Scan get AP records. Sorted list depending based on our SSI. So this. No, that's not what I thought I copied. Here we go. Just that. Different from Wi-Fi get AP records. This only gets one. And then we'll probably need this to clean up after it. So that. So let me do this. I like doing this a lot. I think some people who I've worked with do not like this, but that's too bad. I like to do these blocks that kind of say like, oh, this is like a pre-function, you know? This introduces a new scope. Normally that doesn't mean anything. The compiler is usually smart enough to ignore this kind of thing. Like it's not going to create a new stack frame for it. Unless you start putting in variables in there. But even then, I'm not sure it's... I think it's smart enough to see through most of that kind of stuff. In any case, we got our clear AP list. I think we're going to need that. So once we scan for access points, we're going to look through them, but then it's going to have them stored. So we want to free that up once we get the one we want. Get information of AP to which the device is associated with. Okay, but that... Let me see if I don't think this is going to be relevant for us right now, because this is just how it sounds like this is going to, if it's already connected to an access point, we can get some info about that. We don't care. Power save type, probably going to want that eventually, pretty soon. And that's the query for it. Set protocol. I don't think this device even supports 5G. I think it's 2.4 gigahertz only. So I don't think we need to worry about that. I probably leave it default. The default protocol is 11B, 11G, 11N. So it'll be this, which I believe is fine. If he supports and band mode is 2.4, the default protocol is BGNAX. So maybe it's this. Because I'm pretty sure, I thought this device only supported 2.4G. But I could be wrong. So I suppose we'll find out. Get protocol. Yeah. Set bandwidth. I think we can leave most of these default. Channel, sure. Country, Mac interface. We might be able to set or grab some of this data and show it on the little screen for funsies. I'm not gonna worry about it right now. What else? Set config. I think we want this. Don't we? Maybe we need this way up top. What kind of config are we doing here? Wi-Fi interface. So we need to have an interface T. Where do we get that? Somebody needs to give us that. Where is it? ESP Wi-Fi init returns an int. ESP Wi-Fi init. Aha. So I didn't copy the whole thing. Like a fool. What a fool I was. There we go. So that's where we're going to get our init config. But that's not an interface either. Yeah, where do we get one of... Where'd it go? This one. Where do we get that? Whence that? Oh, okay. Wait. That's just an enum? If that's just an enum... Then we can... Well, okay, so... Well, that's different from mode, though. Okay, does anyone return this? It doesn't look like anything returns the value. Indeed. Okay, so we can just set this. So Wi-Fi interface T. Oh, we need to actually include this. ESP Wi-Fi is the name of the header. So let's include that. Pound include ESP Wi-Fi.h. Yeah. So Wi-Fi interface T. Wi-Fi interface T is Wi-Fi if star. Wi-Fi interface equals. Yeah, we'll do that. I don't want to say Wi-Fi because everything they use is called Wi-Fi, so I'm just going to use interface. I've muted it. Sorry. And then, so that's going to go into these places here. So I can delete that. And just call this air. Do the same thing here. Air equals, air equals, air equals, grunt work. This is the kind of stuff that, like, you would think AI would be good at, but if you just know how to use your editor, like, it takes longer to tell it what to do and then to review the code to make sure it did the right thing. AI, man. ChatGPT. LLMs. Okay. So we know we're going to do that. Back to, what was the last thing we did? Set config. And we're going to need this Wi-Fi config T. Might as well do that. And then instead of that, we're going to do that. And this is going to be some kind of structure. But we probably... Wait, Wi-Fi start. Does this start first? No, first we need to set config. Yeah. So I think that's right. Wi-Fi mode T is Wi-Fi mode Wi-Fi stay. Not interface, but mode. Where's mode? What are the... oh, I had it down here. Wi-Fi mode. Yeah. Wi-Fi mode. Whatever that is. Okay. And then, what is this init config? Init config. Wi-Fi stack configuration parameters. OSI funcs. Oh, lots and lots of stuff. Okay. Any... no, like, callbacks or anything we need to set here? Is there a default that we can just use, so I have to figure out what all these OSI funcs are? Because, like, how do we even get this? Right? This just references itself. So yeah, I don't know. And these have normally been pretty good about giving examples. There are no examples here at all. The examples are in the green. Wi-Fi types, generic. What have we got? What page are we even on here? There's a ton of stuff. Like WNM? What is... I don't know what that is. WNM. Part of the API provided by WPA supplicant. Do we need that? I don't know. I don't know. What is smart config? Mobile application to broadcast the credentials. Oh. Maybe we're gonna want that, but maybe not. So, provisioning API. Let's go back. What are these layers? Okay, yeah. This is what I think there's a HTTP somewhere. Yeah. HTTP server. Nope. Give me client. So this assumes what? We need to give it some kind of connection. Somehow it needs to know that it needs to use the Wi-Fi to do these connections. I think it's time to look at some examples. Because we can't go function by function just reading this thing. It'd be kind of extremely boring. So let's take a look at in applications IDF folder. There should be an examples directory, and there's network, and there's also protocols, but then there's also Wi-Fi. Let's do Wi-Fi. Getting started. Maybe let's do protocols. Look for HTTP. HTTP client. And we'll take a look. What is this? Main. Client example. How's my SSL root? What? Am I gonna need to get Postman for this? I don't know. I don't know if I have Postman installed. Postman. No, I don't have Postman. So, let's take a look. Where is app main? It does some Flash stuff, presumably to store a a bunch of information. So netif init. What is that? Netif init. Oh, that's right. Yeah. The problem with a lot of these examples is that they share a bunch of code, I think. So we have to find this. Let me open a new terminal here in applications, ESP-IDF examples. And then we can look for this function. Because it's not in this file, and it's not anywhere in that directory. These are all calling it. Unless it's a common thing. What's it called? ESP netif. Netif. Where is it? I mean, there's this. Wait. So where? What are you? The ESP netif library is twofold. It provides an abstraction layer. Choose between IP stacks in the future, sure. The APIs it provides are thread safe, even if the underlying API stacks are not. IWIP TCP IP stack. What is this? It's a stack. LWIP? What is this? Yeah, I think it's LWIP. Let me inspect it, because is it a 1? Is that a, I can't tell. It's an L. LWIP, okay. In any case, we do this. But where does it get its Wi-Fi? Back in my view here. Look at the example. Create an event loop. ESP event loop creates default. We'll grep for that. I don't see a definition. Let me do this. These are tests. It's just another library, I guess. ESP event. Okay. And then we got this example connect. So that is going to be where is that? Oops. Git grep example connect in the examples directory. That's a lot of so it's in this this file. Common components, protocol. Common components, protocol. Common. It was an include. Protocol examples, common. What is it doing? Example connect. All-in-one helper function used. Okay, see examples under examples Wi-Fi getting started. Let's do that. Examples Wi-Fi getting started. We are a station. What is this PyTest? Just some expectations, not what I want. Okay. Yeah. Well, let's look at the README first. Shows how to use Wi-Fi station, sure. Well, I think we can do this with some config that I don't have to show you, so I don't have to worry about my credentials leaking. But this is some example output where, yeah, no high level description of what is actually happening. So let's just jump into main and take a look at this guy. So yes. So how does it know? Let me look at the CMake list file. IDF component register, sure. Not exactly what I was thinking about, but there should be. Does it magically know how to pick up these config things? So here's SDK config. That's not what I want. There's another thing in here, a kconfig. Now this, I think, is the kind of thing I want to copy over. That'll set these things and I don't have to put it in directly. I'll have to learn exactly how that works, but that's why we're here. Let's see. Maximum retry 5, scan mode. I don't know what these things are. Are these under? Choice. Okay. So we can figure that out. In the meantime, it's gonna use these macros to do a bunch of actual stuff. So where is there an app main? What is it using NVS for? NVS flash. I think it's saying that's non-volatile storage. It doesn't say, but I think that's what that is. Normally I would see this called NVM for non-volatile memory, but I suppose that's neither here nor there. Okay, so it just does that, and then it... What does this example do, actually? How to use the functionality for connecting. So it just connects to the access point, and that's it? I guess. Let me get rid of this overhead cam view here. It's not currently useful anyway. So we call init station. This does an event group, which is a free RTOS thing that lets us wait here. So this like suspends until it needs to do something. Yeah, the last thing we call is start. And then what happens? Does it just end? Or does it wait forever? Yeah, I don't want it to log my password. If I'm gonna go through to the trouble of like configuring it, probably want to turn that off. But we don't have to copy this exactly. Because also, so I'll keep this around. This is kind of what we want. Except I'm not sure. Waiting until either the connection is established or the connection failed. What else? There's an event handler. Where does this get used? So event handler is register an event handler with Wi-Fi event. I don't know what this is. Set the password and stuff, set the mode, set config, and then start. So it kind of had the right order before, right? Let me see. Hello world main. Step 1. Well, this is using netif. Create default Wi-Fi station. Okay. Creates an event loop. But what I don't understand is, can there only be one of these event loops? Right, these ESP event things. Yeah, there must be like a default event loop or something. Let me take a look at that. Oh, ESP event loop or event handler. Event loop, create default. What is this library? Allows components to declare events so that other components can register handlers. Okay. There's a common case there. So, events and event loops, sure. There's an event handler function. Create the event loop, which outputs a handle to the loop of type. What loop? Default event loop, yeah. As expected. Right. So instead of doing this, it's doing default. And then this loop handle is used here. So, wait, how does it? Okay, so instead of wait. There's this function, event handler instance register. Register an instance of event handler to the default loop. Yeah, okay. So yeah, so there's a bunch of these. That's annoying. We'll deal with it. But yeah, so create some kind of thing, call it the default one, and then register an event handler with these guys. How does the Wi-Fi know to use the default event loop? What is this config default? Is this a thing we define here? Nope. Wi-Fi init config default. Does that exist in here? Wi-Fi init config default. What? Oh, here. Yeah. It exists. So, Wi-Fi init config default should have regular documentation. In here. Hello. Okay. No docs for what you do. I have to look in the code. So that's great. Init config default, if I can spell. It just fills the struct with some magic stuff. No event. No event loop though, so okay. Always use all the fields get correct value. Okay. back here. This is setting the event handler. I don't know how it, I still don't know how it knows to use the default event loop. Right, like how is this ever going to get IP event? That's what I want to know. I don't see it. Well, yeah, this is is it this? Is NetIF doing it? This function here. Where's the terminal? Aha. ESP Wi-Fi default. Let's take a look at this. What is it called? Create default Wi-Fi star. Create default Wi-Fi star. Creates the ESP NetIF object with the default Wi-Fi station config, attaches the NetIF to Wi-Fi, and registers Wi-Fi handlers to the default event loop. Yeah, okay, so that is what's doing that. Just some magic, I suppose. And that's just an incantation we need to know. So, let me start copying some of this stuff. So, there's an event group we're going to create for this X event group create. I don't know what that macro does, but first, let's go to the top. We'll have some variables in here. This is a event group T, is it? What type is this? Event group handle T. That's what that is. Okay. So that'll create the event loop, or event group, and then we can set up the ESP NetIF init. We're going to start handling some of these error things, probably. Sure. Error check. Error. And what should we do with this? This is a neat trick as well, if you're interested. When making C-type macros, if you want whatever you're doing to require putting a semicolon at the end so that you can't do something like this. for whatever reason, then you can put it in a do while, because it is syntactically incorrect to put literally anything other than a semicolon after a do while. So this will execute the block, it'll introduce a scope, execute what's in here, and then force you to put a semicolon there. And I'm not sure it matters, so I don't know what ESP error check does anyway. So let's see. We'll look for define ESP error check. Interesting. So I could just use that macro myself. But what does it do? ESP error check. Why is my bitrate unhappy? No idea. It's not... It's a little wobbly, but it's still high. Like, it's not tanking. Yeah, let me know if it's bad. Okay. In this case, if def and debug, terminate the program in case it's not okay. I suppose ESP error check is kind of what we want. Let's do it. So ESP error check, and we'll create this event loop thing. ESP event, come on, ESP event loop create default. This creates the default event loop. And create default Wi-Fi station. Use the default config t Wi-Fi init config default. ESP Wi-Fi init. So that's what we thought we were using here. Okay. And then ESP event handler instance T. Any ID, sure. Got IP. Error check. Wi-Fi event. So this is like the category. And then this is any of the Wi-Fi events. Call the event handler. And get the value of this. Whoa. The handler itself is going to get stored in that thing. Okay. And then we're going to do something very similar for IP event. And this is only for the got IP event. IP event stay got IP. Yeah, I don't know what exactly is the IP event. What's generating IP events? Is that netif? I assume that's netif. ESP or IP event. Let's look for that. IP event. Do 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 do. Wondering if the music is too high, but no. I mean, that should be okay. I don't know. This guy. What are you? There's a short version. IP events from ESP netif. Okay. Why are we not interested in all the other events? That's a good question. However, not gonna worry about it. So now the Wi-Fi config, which is different from the Wi-Fi config, which is different from the Wi-Fi init config. This is actually going to use our station information, and I'm going to say Compost Wi-Fi SSID, and we'll give it the password Compost Wi-Fi SS or pass. And then I don't know what auth mode threshold resets to WPA2 as default if password matches WPA2 standards. I'm not sure I understand what it's talking about here. So threshold off mode, scan off mode threshold is normally a config option. Oh, I see. Okay. So that's a bunch of config stuff. I'm just going to copy this then. Whoops. Copy this. Big block O macros. No. What the? Jump down. Go ahead and grab this. And then instead of example, I'm going to replace string example with compostmon underscore. Okay. So compostmon ESP Wi-Fi SSID. What do we need? We don't need ESP in there, do we? Let me get rid of that. Compostmon Wi-Fi pass. Okay, and keep all that other stuff in there. So let's keep this comment. But then whence this H2E? Okay, there's more example. Replace string, and we'll do that same thing. Yeah, all the config values say ESP in them. We'll keep that as is. Come on, jump back. Jump back, please. There. I'll keep this. Go ahead and indent, and then I will re-paragraphify this. Oh no. Yeah. Well, how is it? Yeah, let's just do that. Hard wrap, compost mon, Wi-Fi SSID. Oh, I see. It's complaining about the underlying value. I was like, no, I thought I spelled that right, but yes. Those are good, except for example needs to be compost mon. And then we have to actually use the Wi-Fi config. So this set mode to station mode, ESP error check. Oops, ESP underscore Wi-Fi. ESP error check. Wi-Fi set config to the Wi-Fi config. Come on, set config. Okay, and then we set Wi-Fi start. And I mostly had everything in the right order. Incredibly. We can do, sure, use the little log message. What is tag? Tag is just our Wi-Fi? Yeah. Static const. Okay. We also want this event handler, so we'll do static void Wi-Fi event handler. It's got a void star, the event base, an event ID, and then a void star for the event data. And what does it do? So let me look at event handler down here. That's not the right name. We need Wi-Fi event handler, and we need Wi-Fi event handler. And let's take a look. So if the base is, it's a Wi-Fi event, and then the specific event is the station start. Because we are registered for all Wi-Fi events, right? This is the any ID. Okay. So effectively, this is waiting for this is waiting for the station has started message to come in. Wi-Fi event station start. what is this documentation? Feature list. How to write Wi-Fi application. It's not a must, but it is strongly recommended that you read this. Okay. Good thing I found my way here. I suppose. Let's see. Wi-Fi getting started station demonstrates how to use station functionality to connect to an access point. That is an example. That's what I'm looking at. How to scan for available. I don't need to do that right now. I'm gonna assume I know the SSID, and then we can work on improving that once we have the fundamentals. Let's see. Error code, well-defined return values. Yes, we're aware of that. Always check error and handle it. Yeah, sure. Sometimes that's the best approach. Sometimes not necessarily. Yeah, include ESP error H. Yeah, you probably want to do your own error handling code, because killing everything is not exactly the most robust. That doesn't exactly indicate robustness. Like, yeah, you handled every error, you never proceeded when there was some kind of error, but also your thing doesn't work because it just reboots itself if it starts running into a problem. So not the optimal way to do it in every scenario. Sure. There are two approaches for initializing struct parameters. Pick one of two approaches. You can either explicitly set all fields or use an API to get the current configuration, then set your specific stuff. Yeah, we saw this with the Wi-Fi default config. Default init config. And it said, okay, programming model. There's a TCP stack. There's an event. In the event task, which is what we're using is the default one. And then that calls us when an event that we care about happens, which we then use to do API calls to the Wi-Fi driver, which also knows how to talk to this thing. And then it doesn't show, I think, any communication this way. Okay. The Wi-Fi driver can be considered a black box that knows nothing about higher level code, such as the TCP/IP stack. The application code generally calls Wi-Fi driver APIs to initialize Wi-Fi and handles Wi-Fi events when necessary. The Wi-Fi driver receives API calls and handles them and posts events to the application. Sure. Event library. I've seen that. Events are sent by the Wi-Fi driver to the default event loop. Application may handle these events and callbacks registered using that function. They're also handled by NetIF components to provide default behavior. Yeah, so it's something we don't see. This isn't in the diagram. This Wi-Fi events being handled by NetIF. Unless it's considered to be part of this, but I thought NetIF was very explicitly a simple TCP/IP stack. Wi-Fi ready. Will never generate this event. Okay. Cool. I guess because ready might be ambiguous as opposed to done or start. So what is done? Done is as a result of scan done. Seems somewhat self-evident what it means. There's station start. This event will arise. Upon receiving this event, the event task will initialize the LWIP network interface. NetIF. Yeah, see? LWIP was a stack. A simple stack. Lightweight stack. Is that what that means? LW? Is that lightweight? Maybe. Let's see. So these are like informational, I guess. We call start. It says, okay, someone called start in like application land. Here's now an asynchronous event that says that this happened. Okay. I think the example, now that we know kind of how that's working, we can look at the example and get far enough. So ESP Wi-Fi connect. I'm going to look this up. ESP Wi-Fi connect. Connect Wi-Fi station to the access point. Okay. That kind of assumes that this config is stored. Okay. Set config. All right. So then there's two else if branches here. The first one is, again, if it's from Wi-Fi. And the station has been disconnected. Ooh. Wi-Fi event disconnected. Then we'll retry connection. So ESP Wi-Fi connect. If retry num. Is this used anywhere else? S retry num. It's just used there. So we could do this. But might as well just do it this way. And then you don't need to do equals 0 for static. That implies it'll get zeroed out. Oh, that's not my code. That's not my code. That's not my code. So I don't need to change the spacing there. Okay, so if retry num is less than maximum retry, what is this called? Compost mon maximum retry. Connect, increment retry num, and then go ahead and log. Retry to connect to the AP. Whence this log I thing? ESP log. ESP log.h. if it's spelled correctly, that might pull it in properly. Yep. And yeah, okay, it's complaining about what it resolves to. Okay. But the macro itself is good. Now, back in the event handler. If the number of retries has been exceeded, then we say notify the event group with this magic fail bit. So this is defined up here as well. These are interesting macros. Put these with the event group, actually. Event group handle. And I suppose retry num. Okay, and so if it fails enough times, it'll send this message. So, and down here, what this is doing is it's just gonna sit there. But what is max delay? Port max delay. It's listed for waiting indefinitely. Sure. VTest suspend is enabled. It's treated as a special value and will actually wait indefinitely. Interesting. I believe in our case, this is going to be defined. VTest suspend is going to be functional. So we don't have to worry about that. But yeah, so if connecting to wait, when is this log? I'm not sure this log belongs here because if we retry, it will immediately print that it failed. So this wants to go in here. Let's see. And then from the IP stack, if we get event base, if it's an IP event and we've been given an IP, then we're going to print that out. Okay, and then this will say, that that the connected thing happened, which let's look at these bits up here again. Connected bit 0. But then, that's what I'm confused about is what this program does. Like, it just connects and then immediately just returns, I guess. It logs that it connected, and then it returns from app main. Now app main, I mean, it's not regular main. So that means that FreeRTOS is going to call our thing, but what does it do when you start a task in FreeRTOS? Let's say you start a task and it returns. That task finishes. What is all this? Oh my gosh. A hands-on tutorial. What happened to FreeRTOS? Did it get, like, eaten? Where's, like, the API documentation? Here. Tasks and coroutines. So if we do task create, and then I think task function T is this task is this is a function that is the task. So in this case, whatever the ESP IDF is doing, it's gonna set app main as this and pass in as this parameter to task create at some point. The question is, what happens if that function returns? Required RAM is automatically allocated. Yeah. Pointed to task entry function. Normally implemented as infinite loop. Must never attempt to return or exit. Must never. That's a strange thing to say. So perhaps that's not exactly what it's doing. So maybe, let's see. We git grep for app main. We can explore some internals of this IDF thing. Where? Bootloader driver. Let's do. Well, let me do. Maybe instead of that, we can do X task create. Does it have a name? Not in examples, possibly in components. App main, perhaps? No. Send task, receive task, receiver. No app main. Tools. Maybe not in tools, maybe not in examples. I think it's going to be, if it's anywhere, it's going to be in components. But that's a lot of things already in there. So app trace, BT console, driver efuse, driver DAC, ESP event. there's the FreeRTOS kernel. Maybe this guy is going to have an answer for us. App main. Here. Okay. Bootloader happens. Second stage. Which run main task. Okay, so maybe main task. Main. There's main. I don't see a main task. They seem to have... Oh. Here it is. Aha! FreeRTOS app startup. So let's look at that. Yeah, it's just called main task. So less is more. That's a joke. That is nerd comedy. Is that worth explaining? I'll explain the joke. Sure. So back in the day, there used to be this program called More. Now, I think actually, if you do which More, More is what is called a pager. So we can look at something like, this isn't so much an issue now because we use digital virtual terminals, but back in the day, terminals used to be actual like printy text machines, like basically a printer that you could type things on, like a typewriter, and would print all this stuff out. So rather than like you try to print a file, so like, you know, let me look at CMake list like this. So rather than like dump this entire file onto your printer, it would let you go one page at a time if you piped it to More. Right? So More is the name of the program because it prompted you for more at the bottom. And then you would hit, you know, some key, and then enter goes one line, space goes a full page, and it prints out another page worth of content, That's called a pager. The program is not really suited to modern pseudo terminals, these virtual terminals, because you can't scroll up. You can only go down. So if you wanted to go back up, nope, no can do. If you wanted to search for something, you can, but it can only search one direction. And it'll jump to the next thing, and print out that result. What else? It's not very featureful for the kind of interactive terminals that we have today. So at some point, somebody decided we're going to create a more advanced program to do all that, and we're going to call it less, because less is more. So don't use more, use less, because less is more. And that's the joke. Can I do this? /marker. History of less. Marker. Why less is more. Who knows? Maybe it'll be a hit YouTube short. Okay, back to reality. I'm looking for this app main to sate my curiosity. So where was I? I was looking at app startup main. No, don't set a mark. Main task. Main task is a demon. Created by CPU 0. Used to dispatch app main. So it declares that there is something called app main. Okay, so it just deletes itself, as you might expect. And that's actually interesting to see. What does it do? By here, it's already doing all kinds of stuff. Where does it start the task? Not here. This is the task. So where does it? Unicore. Watchdog timer. Yeah. Startup start app. So here's where it starts the scheduler. But where does it create? Oh, here it is. So this is what. So it gets here, and then this kind of just turns over control to FreeRTOS. I don't believe this ever returns. Create pinned to core. That might be a custom pinned. Oh. Let's see. Tasks and coroutines. How FreeRTOS works. There's a task function, v task delete. Yeah, what? I don't know. I seem to recall this used to be better. You could at least search in here, I thought. Now not so much. Alright, well. Oh. Here's X task create. There's the static one. There's no. I assume this pinned to core thing is a custom. ESP addition to FreeRTOS. Because technically this thing has multiple cores. I don't think they're both generally useful. One of them is very low power and has very limited I/O capabilities that let it kind of just sit there and be the only thing on while a whole bunch of stuff is happening. Or be the only thing on while nothing is happening, so that it can just consume no power or very little power while it doesn't have to. And then when something happens, so it monitors some pins and say like, oh, this wiggled in a way that's interesting. And it processes that in some low power way. It can then wake up the big boy's CPU and have that process anything it needs to process and wake up, consume enough power to do whatever it's got to do quickly enough to then shut down again. So that's cool. I don't know that we will be explicitly taking advantage of that. But the reason I was looking into this was to make sure I understood what this example program was doing without needing to run it. I believe it connects and sits there, and if it does connect, it'll print out that it connected, and then immediately just like kill the thing. I don't know what happens if the RTOS runs out of tasks to execute if it just sits there idly. I guess we can try it. There's no harm. We need the environment. And then we need to find the example. So where is this? Examples Wi-Fi getting started station. Examples Wi-Fi getting started station. And then idf.py build. Let's see. Is it P for port? Dev tty acm0 flash. So it should print out that it failed 5 times. And then at the end of that, I'm guessing what's going to happen is it'll reboot. If it runs out of tasks, does it know to reboot? Or is it going to sit there idly in some other task? Error. Wait. I have to do... Let me do help. There's a... Yeah, set target. So we'll do list targets. List targets. And then we'll do set target S3. It'll do a bunch of stuff. And now we can do this again. Hopefully it doesn't have to rebuild everything. I guess it does. That's too bad. It's a nice warm day here today. 70 degrees outside. It's cooling off, I think. It was like 75 earlier, I think. It's crazy. Nearly there. Oh, linking. Yeah, let me know if you would like a tutorial on kind of what the compiler does. How does a compiler work? At a very, very high level. I'm not well versed in compilers. I've been meaning to do a couple of the like crafting interpreters, and then I think it's over there. Yeah, the Dragon book that I haven't actually read is just sitting there. And then I have I got it online. I forgot what it was called exactly. Is it in my books? Let me see if I can find it quickly. Books. I think it's called Engineering a Compiler or something like that. It's a 2-part series. The first one is like writing an interpreter. Yeah. So there's writing an interpreter in Go. And then I thought there was a compiler one as well. From the same person. No. Modern compiler implementation in C. That's not the one. So with this lion, this is not the one I'm thinking of. Well, this is writing an interpreter in Go. But I thought there was a compiler one as well. Well, maybe not. Anyway, we have flashed. We'll monitor. I haven't configured it, so it's going to have some dummy data. Yeah, so init finished. Retry connect, retry connect, retry connect, retry connect. Failed. Main task, returned from app main. So it's detected this. And then it just sits there? Interesting. I guess connecting to monitor reboots it. And this is our code. And main task return from app main. Yeah. So it just sits there. Cool, I guess. Whoa. What is that? All right. Now let's try doing that in our code. Do we need the flash? Because it's doing that. I don't know if it needs to. Let's see. Heap inits by flash. Sure. Larger than size in the image header. Using size in the header, sure. Main task. Where does it do anything with this? There's this NVS Wi-Fi data and RF data. So that must be configured somewhere. Might as well try that here. So ESPRT NVS flash init. Do we need that? Screw it, I don't think I care. Because I don't think it's being used anyway, so unless something relies on it. NVS flash. Let's take a look. There's dinit. Key value pairs, ESP partition API. Well, does somebody care? Because in this example, it's not directly used. Right, if this this netif thing needs it for some reason, that is not obvious from the code. So maybe that's what we need to look at. Let's see. NVS. If NVS flash is enabled by menu config, all Wi-Fi config in this phase or later phases will be stored into flash. When the board powers on or reboots, you do not need to configure the Wi-Fi driver from scratch. You only need to call Wi-Fi get. Okay. I don't think we care because we're gonna, I mean, we're configuring it every time when it boots, so I don't think we care. We don't need that. Awesome. So then now we just need to do this kconfig thing. Do we just create it in here? So kconfig proj build. And we'll have a look. So there are Compost mon. Okay. Menu. Compost mon configuration. And is there a kconfig mode? No. Package list packages. Let's get that kconfig. Kconfig mode. What is this? Simple package for looking up kconfig symbol quick. No. Go ahead and install kconfig mode. Kconfig mode, please. There we go. Then we want to config this value. And then what else? I think we can just take everything that says config ESP and yoink it. So, nope. Control X. Oi. Config. And what is this? Where did the retry go? I like that down there. Wi-Fi SAE mode. I suppose we can just copy paste this whole thing. Choice. No, come on. Proper indent, please. I hate it. Bloody hell. Alright. Go away. Copy this whole block into there. For some reason, the default indentation is 5 spaces. So, I'm gonna insert a space there, and then and then then it's 7 spaces. What the heck? That makes no sense. Oh, because it's inserting a tab? Why is there a tab there? That doesn't make any sense. Really strange. All right. Let me do this. Nope. It's stupid. Okay. SAE mode. So this is the choice of what to set for this. Then we have to have all this complex logic in here. So isn't this done by this guy? if ESP Wi-Fi or ESP WPA SAE PWE. Yeah, this looks really unwieldy, whereas this would be, theoretically, you should be able to make something simpler if it's got a choice. I don't know. I'd have to look into kconfig a little more deeply than I care to right meow. So why don't I just copy this whole damn thing? So give me this. Drop that in there completely. Config, SSID. Is it smarter about it if I... No, it's just dumb. Okay. No. All right. Leave it untouched. We don't want to call it this. We want to call it Compostmon Wi-Fi SSID. Or no. Leave it at that. So this should create config ESP Wi-Fi SSID. Same thing here. The only thing is if it has example in it. That's it. There aren't more. ESP maximum retry. Maximum retry. Yeah, that should be fine. So then run the build. Actually kill this. Go back to the project. Run the build. I did not. Now, presumably, the station example will have some way to get the config pulled in. Config ESP system. ESP system. Oh, that's already in there. So, are these all just passed as like command line parameters? Let's see. So in the top level, this is for some kind of CI thing. So yeah. So let's look at CMake lists. At the top level, they match. They're exactly the same. Okay. Then if we look at main, I've added this proj build thing. And then in CMake lists, I've got include deers, including nothing. Do I need to do this? And then it'll work? So anyway, waiting for the ninja to finish ninja-ing. Da 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 da. Da 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 do. Nope. Ah, okay. I think that was it. I think that without this, it can't find the macros? No, now it found the macros. So I don't know what changed there. Let's clean this and see. I didn't even use the IDF Pi build thing. But I'll keep that in mind. So really the errors now are just around whether Hello World main is calling what it ought to be calling. So let's finish doing what the example does, which is to just wait for the yeah, I'm trying to decide whether it's okay that this is gonna like just sit here forever waiting for the Wi-Fi connection to finish. So I guess just for testing, let's do it first, and then we can split it off into its own task. Wait bits, the event group. We've defined the connected bits and the fail bits. False, false. Port max delay. So that should wait indefinitely. And then returns the bits before the call returned. What does that mean? X event group wait bits returns the bits before the call returned. I don't know. I don't know what it thinks that means. I think it's saying that, like, when it returns, it'll take a snapshot of the state of things so that it's what you expect. Which is what you'd expect, so I don't know. I don't think it matters. Yeah, I don't think it matters. So, moving on. Hello? Let's just check what bits it is. So if it's the Wi-Fi connected bit, that means Wi-Fi was connected. If it is the else if, it's the Wi-Fi fail bit. Whoa, my keyboard. Wi-Fi fail. Failed to connect after several retries. And then else, this should be impossible. Tag unexpected event. And yeah, I guess we can just print the SSID and password. I'm not going to do that. And just say, yeah. Failed to connect to AP with given SSID. Yeah. And then it'll go into the other thing. Cool. So, let's give that a shot. Now, I actually don't expect, because we didn't run kconfig or anything. Oh, config? Kconfig? No? Help. Help! Bootloader flash, conf server, no. Menu config, that's what it is. Menu config. So, Compost mod configuration. I'm going to do this on this screen over here. Well, let me check this. I'm just going to say test SSID. Let's see. Jose test SSID. And then I'll give it a password. Jose test pass. Jose test password. Make it long. I'll let you see this. We'll leave these defaults. So we can hit quit, save config, and then run tdev tty acm flash. And actually, let me look at the help here. Can I specify multiple targets? Command args, command arg. Oh, okay. So I could do build. I could do theoretically flash and then monitor in one step. That seems like what I'd want to do most often. Compiling. All right, let me try this. Flash, and then I to monitor like this. Theoretically should work. And actually, let me keep an eye on here. Does the, what did I call it? Jose test? Something like that. Oh, hello. We're panicking. What is it doing? Okay. End of partition table. Hello world. Restarting probe. OSI NVS open fail. Fail to unregister RX callbacks. NVS not initialized. I thought it was optional. It made it seem like it was optional. I guess it's not optional. So let's copy that as well. This NVS flash stuff. I think we have to add it to main CMake lists NVS flash. Is that what it's called? NVS flash. Here. Yep, requires NVS flash, and then in here, pound include NVS flash H. Yeah. And then we call flash init. That's not how you spell NVS flash init. ESP air T ret is this, and just copy the example. Okay. Well, we'll say printf hello world, and then we'll do ESP log I. No, just print. Puts initializing NVS flash. And I've theoretically called. Oh, I haven't built, so it won't. My thing won't pick that up. What is up with my bitrate being so unstable right now? Is it... I mean, I don't have anything running that I don't normally. Nothing on desktop 2. Yeah. As far as I can tell, there's no reason for it to be unhappy. So... who knows? Okay, so now this should pick itself up now. Building it worked. So flash and monitor. Interestingly, normally you have to like configure the flash. That doesn't seem to be the case here. So that's, yeah, that's identical. We saw that before. And yeah, there's nothing that says here's the configuration of the flash, so... Oh, hello. Failed to connect with a given SSID. And I was actually trying to look for... how does it... does that just exist in the build directory? I don't see like Jost test def or whatever in here, so that must just be like an internal build thing. So let me see about SDK config diff SDK config.old with SDK config. Okay, so it's just in here as a file. End of deprecated options. These are deprecated options for backward compatibility. Interesting. How come this wasn't in there originally? I don't know. Who knows? All right, that's good. So now I'm gonna do on this screen. You can't see this. Don't look. What is it? idf.py menu config compost mon configuration. And I'm going to set my SSID to my actual SSID. And my password to my actual password. Okay. Save. And quit. Okay. All right, I think that's correct. And nobody look. Okay. Not many config. Flash and monitor. Let me make sure actually that it's not going to print out anything incriminating. I didn't. We're not printing it out, so it shouldn't see it. But we're about to find out. Is it gonna work? I think that means it works. We got an IP. There it is. That's its IP. I should get like an alert that some new Wi-Fi, new devices join your network maybe, but perhaps not. Aha, there it is. Espressive has joined your network. Amazing. I think that means that works. That's pretty cool. It's not too tough. Relatively painless. It took a little while. Mostly because of all the weird tangents and deep dives. But yeah, now we gotta start cleaning up some of the logic here. For real. So let me, I'm actually gonna do this in another frame. Because I don't want, I want this menu config file. Shoot. Because it's showing me. Okay, I want kconfig proj build in there. But then I think I want to ignore SDK config, and do I want to do that like forever? ESP IDF commit SDK config file. Should you commit these? They're text files that contain the kconfig items in the form of key value pairs. Preset configurations. By default, it sets... Okay. Target specific ones end with the target name. Okay. In most common CI workflows, the project is built with different configurations. Different combinations of configuration options are tested. So yeah, we defined some rules, whatever. But then what if we have something that we don't want to commit? So, should you commit SDK config? You are not supposed to commit SDK config. I was notified that that is incorrect. Okay. So when I'm ready to upload new changes to Git, I have to manually copy and paste all the changes and put them onto SDK config defaults. Perhaps I don't fully understand how SDK config and SDK config defaults work yet. What is the optimal way of making changes in menu config and pushing those changes to the repository while avoiding the issues? There's a shortcut to do the defaults. You can commit it, but the file is unstable. What? What? What is it saying? VS Code, PowerShell, build the project without any SDK config conflicts. We have multiple people working on the same project. Whenever someone makes changes and push to the repository, whenever other people try to pull all the changes and build a project in their own machine, during build process, something changes on the SDK config H file. I want to understand, why does that change when the project is built on different machines, even if the same thing is used? Are they saying... I'm not sure. I think maybe having committed this was a mistake. So let me see. Right, so there's the defaults. Then there's some more specific ones. Then they generate... There's target specific things. Okay. In general, these files... It links to itself. Cool. Preset configurations. Links to itself. Amazing. Okay. this just jumps down to... Okay. Not particularly useful. But I don't suppose we have any use for defaults. So how do I think there's a trick. I think it involves editing history. So how to remove committed file git. How to untrack a file git. Git clean X. The only right answer is update index, assume unchanged. No. If you want to keep the file but remove it from git tracking, users often try to use the assume unchanged and skip worktree to tell Git to ignore changes to the files that are tracked. This does not work as expected. Because Git might still do stuff. In general, Git does not provide a way to ignore changes to tracked files. Therefore, still consider doing this. Ooh, well, I think even if it's removed, it's still tracked. So I have to like edit all the history. This is not the real answer. Get ls files ignored. Yada yada yada. What does this do? Get rm -r cached. Okay. Let's say you've already added some files to your repository and you didn't add them to your git ignore. These files will still be present in repository index. In this article, we'll see how, what? This is an article. Oh, okay. By this guy, Mr. Klugertz. Klughertz? Kluffertz? Because of, yeah. Because English is insane. Okay. This will delete everything. Not exactly what I want. Well, that's ridiculous. From the index. What? This won't delete anything from the history. Yeah. I don't know. Maybe that's the way to do it. Git filter brand. I haven't pushed it, so I can just rewrite all the history. I think that might be the way to do it. So let me... I feel like SDK config should not be committed. That's my opinion. ESP IDF, should you commit SDK config? Per configuration? No. Configuration guide? What are you? Hey, this robot's back. He's not here. Yeah, you do menu config. Yeah, I think committing it at all was a mistake. So let me do git filter branch. Git filter branch remove. Maybe it's their. They're using root there. Yeah, leading slash. Yeah. Okay, let me commit everything else. So, get rid of that. Do that. Kill this. And I'm going to... Okay, you can't see this. Oh. Here. So. Note to self, do not do git diff. So I'm going to git commit. Connect to Wi-Fi access point. And do nothing else. Okay. And now we figure out how to do git filter branch. Why is it so far to the side? Okay. Git filter branch. Plethora of pitfalls. Yeah. Please read safety. Riddle the gotchas. Easily corrupt repos. Some examples are affected by this. If lucky, you'll get error messages. Well, okay, so what is git filter repo? Is that a built-in command as well? No. Plugin. It's a separate tool. I don't want it. Let me go back to this guy. Okay. I think the trick is git filter branch. Git help filter branch. What is each of these options? Filters are applied. Order listed below. End filter. If you only need to modify the environment in which the commit will be performed. Tree filter. This is the filter for rewriting the tree and its contents. The argument is evaluated in shell. The working directory set to the root of the checked out tree. The new tree is then used as is. Disappeared files are auto-removed. Git ignore nor any other ignore rules have any effect. Index filter. This is the filter for rewriting the index. It is similar to the tree filter, but does not check out the tree, which makes it much faster. Frequently used with rm cached ignore unmatch. for Harry cases C updated. So let's jump straight down to examples, since it seems there's such a thing. Suppose you want to remove a file containing something confidential or a copyright violation from all commits. So this is our target. We need to be at the root, which is actually a level up. So git filter branch tree filter, and then just rm hello world / SDK config head. Will fail if the file is absent. If you want to completely forget a file, it does not matter when it entered history, so we also add ignore on match. Okay. Well, we don't have that much history, so this should be fine. Let's try that. Okay. I have unstaged changes. Yeah, that's... Okay. Git restore SDK config. Git restore hello world SDK config. And now run the filter branch. Oh, that's right. It didn't used to be there because we had a bunch of commits before we even added the Compost Mon Hello World project. So it should die in short order. Is that it? Okay, so now IDF pi, going to hello world, IDF pi menu config. I don't want you to see this in case it's still in there. It is not. It's currently set to some defaults. Okay, so this is currently set to my SSID. Let me use Joe's test SSID again. Oh, and Joe's test password. Quit, save, and then git status. Aha! Weird that it has an old when there didn't. Short. Automatically generated, do not edit. Right, if it's automatically generated and you're not supposed to edit it, then there's no reason to commit it as well, because you can just automatically generate it. Build type, where's my Joe's test? Config. Compost Mon configuration, Joe's test SSID, and Joe's test password. Perfect. Echo SDK config to git ignore. Okay, and then also echo this guy. Maybe I should edit it so that... Oh. These should be at the root. Git diff. Okay. Oh, git add everything. and then commit update git ignore to ignore SDK config. And why? Oh, are these here just in case? These are the non-rewritten ones. So let me see. Git show SDK config. No. That's fascinating. There's only one branch, but for some reason these commits, which aren't merged either. That's very strange. Those should be orphans. We do git GC. That should clean them up. Which hopefully isn't a mistake. And we don't find that we needed something in there. I doubt it, but who knows? You never know. Okay, so now if I run the one log, it's still there. Okay, that's very strange. Okay, so if I do git checkout this commit, their SDK config is committed. So back to main. Yeah, all branches. That's very strange. So those aren't completely abandoned. All right, let me try that again. Menu config. I'm not going to show you my SSID. At least not on purpose. Save that. All right. So now even with an SDK config in here, Git is clean. So connect to dev tty acm0. We'll do Flash and monitor. There's nothing interesting happening with it, but there it is. Almost there. 80%. 90%. Of course, the last 7 take up the most time. Okay, now we're flashing. Then it should report that it can connect to my Wi-Fi. Did it have to reboot there? No. That was just all the output. Connected to AP. Got an IP. Same IP. All right, cool. Very, very cool. So, now that we have that, I guess the only thing left is to start cleaning it up. so that we can actually send a request. I'll have to do some investigation. I'll cut the stream short today. It's 5 o'clock. I've got somewhere to be at 7, but I have to eat dinner before then. So now might be a good time to pause and end the stream, but yeah, I have to investigate. I'm pretty sure that there is a way to do the network connection in a way that's very low power. Let's see. What if I just search for power? Can we get consumption measurement? I2C low power mode in Wi-Fi. That's what we want. Can I? After the previous introduction to low power mode from a systemic perspective, this section delves into low power mode in Wi-Fi scenarios. Due to the complexity of Wi-Fi scenarios, basic principles of Wi-Fi power saving will be introduced before a specific low power mode. Focused on station mode. That's definitely us. You. Definitely station. Okay. Basic principles of Wi-Fi power saving for specific modes. Well, this seems like it's first introducing specific modes. So let's see. Item. Sleep, wake up, wake up. Okay. I think we want Wi-Fi connection maintained. It just has, there's just no info for anything other than deep sleep. Peripherals are on. We just want I suppose the question is whether maintaining the Wi-Fi is less power than re-establishing it every time we need it. Right, so if, you know, if the power consumption of, I guess maybe we can draw this. So if the power consumption of maintaining the connection, like the steady state, is low enough, and then re-establishing a connection is actually more expensive. Let's see. Here's GIMP. So let's say we got time. We got time on the one hand and power on the other. Okay, so there's two scenarios. Let me pick a different color here. I'll do red for one. And we'll say this is we'll do this is, you know, whatever. And then this is some kind of peak. I don't know. Maybe we don't need that. The access here is current. Current. That's an E. You can tell because it's huge. So the current, and then here we got time. Time. If we're saying that like, oh, once a minute we're gonna wake up. So this is 1 minute, 2 min, 3 min, 4 min, and so on. And let me pick a color. I'll do kind of a gnarly red. So let's say that normally, so it's at this level, and then it wakes up, consumes a bunch of energy, reading the sensor, doing whatnot, and this will fluctuate, you know. And then it's done. And then do it again. And then at the 2 minute mark, comes back up, wiggles, Bart Simpson, boom, Bart Simpson, oh, no, redo. And then, you know, same thing again. And so you get the idea. So the question is, so the red is the first mode that I'm saying is no reestablish. This will say disconnect. Disconnect. And so here, this whole time Wi-Fi is off during this low period. So according to this sheet, 6.8 microamps. 6.8 U. That's a mu. It's a backwards mu. Microamps. Nope. Microamps. Can't read that anyway. But then it peaks at something X, right? So it wakes up, establishes Wi-Fi. Right. During this period, it's disconnected. Up in here, it's disconnected. But then up here, it's connected. Now the question is, does that, we contrast it with, I'll pick like a blue, and we'll say if the connection is maintained, then, why isn't it blue? If the connection is maintained, then maybe, you know, the current consumption at a steady state is higher, but then when the minute comes up, maybe it only jumps up that far and is able to stay on for less time. Right? Draw skills are good. So instead of a Bart Simpson, it's just a matchstick. You can't even see the fluctuations there. Okay. Right, so theoretically, if you do the integral of this, right, you have to figure out which one's bigger. But maybe this isn't true. Maybe most of the time here is just spent in the communication portion, and establishing the connection is super negligible in terms of power. So like you turn it on, it takes an extra several milliseconds maybe of high power, but you've saved all of this energy, right? this is all savings. Even though this in here is costing more. But what if, you know, what if this distance is small? This delta X here is tiny. So then these savings add up to more than that. So have to do a little bit of math, a little bit of thinking, maybe some measurements to figure out exactly what the right answer is, because this table doesn't give us the information we want. Right? It just gives us the 6.8 microamps of average current in deep sleep mode, but then yeah, all currents in the table are average. Yeah, and then there's only one measurement. So let's see. Basic principles of Wi-Fi power saving. During the operation of a station, prolonged channel monitoring is required to avoid conflicts during transmission and reception. It leads to significant energy consumption as the RF module remains active, thus wasting power. Wi-Fi protocols introduce power-saving modes. The basic principle of power-saving mode is to reduce energy consumption by minimizing unnecessary monitoring time. Access points will cache packets for a station that has entered power-saving mode. At the same time, it will periodically send beacon frames containing traffic indication map information. TIM indicates the unicast packets cached by the AP. Within TIM, the delivery traffic indication message, it's a different TIM, a different M on DTIM, is special as it caches broadcast packets and sends them out periodically every N TIM intervals, as determined by the access point. For stations, TIM is optional listening, while DTIM is mandatory. Therefore, a station can choose to wake up only before each DTIM frame to power up Wi-Fi related modules, instead of constantly being in a listening state. This effectively reduces power consumption. Yeah. Second, the time from powering up to powering down Wi-Fi related modules in a station also affects power consumption. Apart from the necessary time for data transmission processing, there are 4 configurations mainly affecting the duration. Time offset caused by clock accuracy. Time spent processing missed beacon frames. Active time to ensure the reception of burst data, which can be determined by configuration, and ILD time. That seems to be a typo. I believe it's idle, because it's idle here. Furthermore, when the station is not in a Wi-Fi transmission or reception state, other modules begin to affect the chip's power consumption. Different power-saving modes will configure different clock sources or dynamically adjust the operating frequencies of certain modules, such as the CPU, while also shutting down varying numbers of functional modules, which effectively reduces power consumption. Yeah, sure. If time is plotted on the horizontal axis and current on the vertical, then the ideal current consumption graph of the chip under low power mode can be simplified as shown below. There's some base, you know, it just needs to, feeding it power consumes something, the base current, and then the interval and the period. I think these are strange. This is a strange naming convention to call this period, because something that's periodic will repeat. So probably more accurately just called duration rather than period. Anyway, yeah, so this is what I'm talking about here. I guess this is just inaccurate in my diagram. So really, being on, well, I don't know what normally this interval is, but if it's on the order of seconds, then there would be in the blue, instead of it being maybe I'll use yellow for maximum confusion. So instead of being a straight line, it's at the baseline, then bumps up for a little bit, bumps up for a little bit. And this is much more square here. But I don't know how often these have to happen. Let's see. Furthermore, when the station is on a Wi-Fi, yep, we read that. Idle current graph of the chip under low power mode. Yep. The main factors are the interval. It can be customized by low power mode or determined by the DTIM according to Wi-Fi. Generally, a larger interval leads to better power performance in the same conditions, but also results in slower response times. Period can be seen as the duration of each station's Wi-Fi. Of each time the station's Wi-Fi operates. Yeah. Period is not fixed. Sure. In ensuring normal Wi-Fi communication, a shorter period leads to better power performance. However, reducing the period will inevitably affect communication reliability. Interesting. Base current. Current of the chip when the Wi-Fi related modules are not active. There's various factors based on sleep strategies. Okay. Modem sleep mode. Based on the DTIM mechanism, in this mode the chip periodically wakes up for Wi-Fi related tasks and enters sleep state between the intervals to power down the the physical layer, to reduce power consumption. Besides, through the DTIM mechanism, the station can maintain Wi-Fi connection and data transmission with the AP. Yeah. Modem sleep mode automatically enters sleep after the Wi-Fi task ends without the need to call an API. During sleep, only the Wi-Fi related modules are closed, while other modules remain powered up. Modem sleep mode will wake up according to the DTIM interval or listen interval, acting as if the system has automatically set a Wi-Fi wake-up source. Therefore, users do not need to configure a wake-up source. The system can also wake up when actively sending packets. Modem sleep mode is a toggle mode. Yeah. But I think this base is relatively high in modem sleep mode. Yeah. Generally used in scenarios where the CPU needs to remain active and maintain Wi-Fi. We don't really need that. I mean, we don't really need more than like once a minute readings. If that. Like, that's pretty high resolution data for what we're trying to do. We don't need up to the like, I'm not gonna run out there and like throw an ice cube into my I was trying to close that. I'm not gonna like throw an ice cube into my compost if it's getting too warm. So a minute is plenty. Modem sleep and DFS. CPU remains active while the DFS mechanism primarily adjusts the CPU and APB operating frequencies to reduce power consumption. I don't know what DFS is, and I don't know what APB is. What is DFS? DFS. Let's look up DFS. DFS? No, not on this. DFS. Dynamic frequency scaling. Okay. It adjusts the advanced peripheral bus frequency based on power locks. Okay. Suitable for scenarios where the CPU must remain active, but low power consumption is required. Okay, so this is getting into much more detail on this. In fact, it's the same section. I guess. Weird. Okay, DFS. Well, I already forgot what it stands for. Dynamic frequency scaling, and then APB is architecture peripheral bus? Or was it? Advanced peripheral bus. Okay. DFS mechanism primarily adjusts the CPU and APB operating frequencies to reduce power consumption. Therefore, combining DFS with mode of sleep can further optimize power performance. Additionally, as the Wi-Fi task requests the frequency mass power lock to ensure the rapid execution of Wi-Fi tasks, frequency adjustments by DFS and modem sleep mode only occur during the base current phase, which is after the Wi-Fi task ends. Okay. Yeah, that's fine. Auto light sleep mode and Wi-Fi scenario. Auto light sleep mode combines the IDF power management mechanism, the DTIM mechanism, and a light sleep mode in Wi-Fi scenarios. Enabling power management is a prerequisite of this mode, and its auto aspect is demonstrated by the system automatically entering light sleep after being in the idle state for a set duration. Additionally, auto light sleep mode adheres to the DTIM mechanism. The system will automatically wake up to maintain Wi-Fi connection with the AP. The condition for entering sleep is when the system has been idle for a duration exceeding its set time. The system will assess if the idle time meets the conditions, and if so, it will directly enter sleep. This process is automatic. During sleep, RF, the 8 MHz oscillator, the 40 MHz crystal, PLL stands for phase locked loop, which is a hardware implementation of a timing mechanism, and gated digital clock are automatically turned off, and CPU operation is suspended. Auto light sleep mode follows the DTIM mechanism. The system will automatically wake up before the arrival of DTIM frames as if a Wi-Fi wake-up source has been set. Therefore, there is no need for configuration. Additionally, the system can be awakened when actively sending packets. The operation of this is relatively complex, but is entirely automated throughout. Specific details illustrated in the diagram. Fun. Active. We become idle. We are idle now. Dynamic frequency scaling kicks in, and after some amount of time, it even gets lower power. And then on DTIM intervals, or when something needs to happen, it goes back to the active. Similarly from idle. Yeah, that makes sense. That's kind of what I want. And then here's how you do it. Okay, deep sleep mode, essentially the same as in a pure system, therefore detailed instruction of configurable options. The performance of this configuration mirrors that of the recommended deep sleep mode configuration of pure system, combined with the default Wi-Fi related configurations. Average current approximately 6.9 microamps. I wish it gave me some idea of the current in the other. Oh, here it is. Auto light sleep. Configuration mirrors that of recommended auto light sleep mode in a pure system environment with the default Wi-Fi related configuration of the Wi-Fi environment. Okay. So I guess it peaks at 120 milliamps when it's doing Wi-Fi. So this is giving me some idea. So I average. I guess this is why they don't say, because what does it mean? Average of what? Given that what is on? Is it just the modem and it's like crunching numbers, or I don't know. Yeah, I'll have to. I think I will apply this offline and do this before Tuesday. On Tuesday, I'm gonna refactor the code in here so that it's a little bit more modular and we're not just all in one function. Yeah, and then it'll be designed with an eye toward actually showing actually uploading the data from the device to the web server, and I think I'll have that running as well before then. And then I can just show you what it's like without having to struggle through it on stream. Okay. I don't have an outro song that I've picked yet in my chill hop playlists. But that's it for today. Follow me if you don't. I need to get to 20 followers. And then Twitch will start to take me more seriously. I think. I'm not sure what it needs. And then I also need 3 concurrent viewers on average per stream. I'm over 1 right now, which is pretty good for me. So, yeah. Thanks for watching. I will be back on Tuesday with some more. We'll finish up this Wi-Fi stuff and then actually start collecting some data. And I'll peruse peripherals to try to do more of the fun stuff. This is way more fun to like actually do the hardware integration with I2C and whatnot, and maybe dive into something a little bit more low level and replace some of the IDF drivers with our own. But I don't know. We're not there. We're not there just yet. I want to get the data collected and then go from there. So yeah, thank you for watching. I'll catch you on the next one. Peace out.